Welcome to qnawire.
All right. So in this problem, we have known the expression of the electric field. So E equal 3.1 times 10 to the fifth voltmeter, and times the vibration term cosine kx minus 12.65 times 10 to the 12th t, and direction is along k direction. Yeah. So this is the expression of the electric field. So because this is electromagnetic wave, we can determine the k based on the omega. So we have relation. So firstly, we can. So let's just do it step by step. In part A, we want to determine the direction of the magnetic field by knowing the direction of the E field, because we know the E field is along the k direction, which is the z direction. So there is a trick for you. It's because we have three vectors in the electromagnetic wave: the E vector, B vector, and S vector. So S vector is the pointing vector, and the expression of the S vector is it is proportional to E cross B. Okay. So these three vectors, they are perpendicular to each other, and the direction of them, they following a cyclic rule. So for example, if E is along I direction, then B is along J direction, and S is along Z direction. Okay. And also, for example, if E is along J direction, then B is along Z direction. Sorry, I should not use Z, I should use K direction. Just IJK, right? So this is the K direction. This is the K direction. And this one should be I direction. And if E is along K direction, then B will be along I direction, and S is along J direction. Okay. So these three vectors, they follow this cyclic rule. So in this way, because we know the E in this problem is along the k direction, so we can easily see that the B is along, so k is here, right? So B is along I direction. Okay. So this is part A. And in part B, we want to know the wavelength of this wave, because we know the angular frequency is 12.65 times 10 to the 12th rad per second. And for the electromagnetic wave, we know the speed is a constant, which is the speed of light. So we can see that lambda over c equal t. So t is the time, is just the period. And we can obtain c over lambda equal f. F is the frequency, which also equal omega over 2 pi. Okay, so this is the omega. So we can determine lambda by using this relation, and you can get to the value of lambda by solving this equation. Lambda equal 0.149 millimeter. Okay, and at the same time, you can also get the wave number k. So k is the 2 pi over lambda, and this gives you 4.22 times 10 to the fourth meters inverse. Okay. In part C, we want to find out the vector representation of this B field, because we know the magnitude of the B field has relation with the magnitude of the E field as following over C, right? So because we already know the magnitude of the E field from the problem itself, so we can determine this value very easily. This is 1.03 millitesla. So we can write the B field in this way. So the magnitude is 1.03 millitesla. And the direction is the one we found in part A, which is along the I direction. Oops, I direction. And then it's the vibration term. The vibration term is identical to the E field. So it's 4.22 times 10 to the fourth times y, and minus 12.65 times 10 to the 12th times t. Okay, so this is the vector representation of the B field.